All right, look back across the page if you would now, page 118. Back across the page, page 118. And on the back side of your homework or on a new sheet of paper, I want you to go ahead and copy down the picture for number 1 there on section 2.30. So page 118 across the page from where we just were with the homework. Number 1 on exercise 2.30, we've got this short, wide triangle that has another little triangle coming down from the inside. The larger triangle's ABC, and then the 2 lines coming down are CD and CE. Now, do you see, it doesn't actually say the word given here like it did in the homework last night, but it does say if. Well, that's the hypothesis. That's the given, if you will. So, apparently we are given that AC equals BC, and we're given that AD equals BE. You'll notice those lines are marked as equal on the sketch for you already. All right, so given AC equals BD and AD equals BE. And it says to prove, and we're going to prove a couple of different things here. First of all, we're going to prove that triangle ADC is congruent to triangle BEC. And we're going to prove that triangle AEC is congruent to triangle BDC. Once you have that copied down, 2 columns, statements, reasons. And we'll get down your first statement and your first reason. Of course, we said that every proof that we work, the best way to approach the proof class is to start synthetic. Good. Start with the clang. Start with the synthetic approach. And there is a little bit of synthetic clang actually in the given. What's the clang that's in the given, Dylan?
Equal signs.
AC equaling BC. 2 equal sides. Because ABC class is a triangle with 2 equal sides. Clang class. I could state it's isosceles. I don't necessarily need to. Equal angles. What are the equal angles, Dylan?
A and B.
So we should say in number 2?
Angle A equals angle B.
Angle A equals angle B. Reason, Dylan.
And a triangle angles opposite equal sides are equal.
Good. How many thinking what Dylan said? All right. Any other clang? Lana?
Any parts of them? Like A, D, and B?
Well, I don't know that it's necessarily clang, though it's certainly something that could be useful that these 2 parts, and it's a good observation. These are merely parts of lines. I'm looking at something here, I'm like, wait a second. I got these 2 lines equal, these 2 angles, these 2 lines. What's kind of a synthetic thought? I'm just looking at the picture class. I got a couple little congruent triangles here by side angle side. Not sure if that helps or not, but let's go ahead and call this triangle class triangle ADC. And it's going to be congruent to triangle BEC. All right? And reason class? Yeah, just kind of sitting there screaming at me. Let's take it. Any other clang? Let's look at what we're trying to prove here. I'm trying to prove, first of all, that triangle ADC is congruent. How about that? That was a synthetic proof, completely done synthetically. No analysis needed. It just sort of fell into my lap. Doesn't happen often. Not much is done. All right, let's look at the other thing I'm trying to prove. And we'll do a little bit of analytic thinking here. I'm trying to prove also that AEC, that's this piece here, is congruent to BDC. And we'll put the dotted line around that one. Well, what do I already have for getting those triangles congruent, class? I've got some sides here still, right? I've got some angles right here. Side angle, I would need something else. Brandon?
Side.
What sides?
AE and BD.
Are AE and BD equal, class?
Yeah, yes. Right.
Do I know that they're equal? Like, have I stated it yet?
No.
No, but I could get it very easily, right? That's one way we could approach it. The thought would be kind of building on what Lana was insinuating a moment ago. We've got a couple class of equal parts, and since these two lines, BD and AE, they share class,
Equal.
they share
DE.
DE, which of course would be equal to itself. So I would have equals added to equals.
Equal.
The sums would end up being equal, right? It'll take a few steps to get it, but I could do it that way. That's if I wanted to say side, angle, side equal to side, angle, side. And it would have another way. Noah? I could already state, could I not, that this line here and this line here are equal because they're corresponding parts of these two congruent triangles, right? However, that would give me side, side, angle, and side, side, angle. And is side, side, angle a way of proving triangles congruent, class? No. No. All right, so we're not going to use that. Any other thoughts? Michael?
We could do angle, side, angle, and stating that angle D and angle E are equal.
Oh, angle D and angle E are equal.
Yeah, I was thinking because they're equal, and then we could do the subtraction axiom and substitution axiom, and then DE is already equal to DE through identity.
Okay, I see what you're going. So you're actually saying side, angle, angle, not angle, side, angle.
Mm-hmm.
Okay, yeah, you said angle, side angle, so that's picturing up here. We could do side angle, angle as well. We could work our way toward getting, by subtraction, let's call this 1 and this 2. Since these angles are equal by CPCTE, these add up to straight angles, subtract. These would be equal. We have side angle, angle equal to side angle, angle. That could work. I was actually seeing when you said angle, side angle, I was thinking if we could get these two little angles equal by CPCT, and therefore if you added this piece, you'd have all of this angle, add this piece, you'd have all of that angle, angle, side, angle. A lot of options. Let's go with the first one mentioned though, and that was the side, angle, side. We already talked it through, it was the first one we approached. Let's go ahead and take that approach. Not that any of the other methods are wrong, right? Just making a point, more than one way to do it. Let's go ahead and specify first of all that AE is equal to what, class?
AD plus DE.
AD plus DE. Because
So we hold equal to some
and similarly, someone besides Brandon,
BE is equal to
BD equals DE plus EB. But since we know that AD and BE are equal, and we know that DE is itself equal, then we could simply say that if equals AD and EB are added to equals, the sums class are equal. That's the addition axiom. We have equals here, we have equals here, equals are added to equals, sums are equal. Addition axiom. And since AD plus DE equals EB plus DE, we can follow up our whole sum of parts, addition, substitution. What can we substitute here, Adam?
Substitute. You could substitute AD.
What can I put in place of this?
You could put in AE.
AE could go in right there. And what could go in place of that?
BD.
BD could go in right there. That's simply a substitution. Those three steps, again, we've seen them a number of times. Whole equal sum of parts, addition, substitution. And then class, since this whole line does equal this whole line, we have side, angle, side. Number 7, the triangles are congruent. Triangle AEC congruent by triangle BDC, congruent to triangle BDC by, again, side, angle, side. Questions on that? Drop down now, if you would, to number 3, right below where we just were. Number 3. Maybe on the back side of what you were just on, or a fresh sheet of paper if need be. Kind of an interesting looking drawing here in number 3. Got a long line, A, B, and there are a couple of lines coming up off of A and B. AD and BC are marked as being equal. And then lines come down off of D and C to mark off equal distances F from A and E from B. So there's kind of our picture here in number 3. What will I put in the given? Reckon?
AF equals BE, and AD equals BC, and D equals CF.
Good. Where it says if, that's what we're putting in. Now, they don't have 3 sets of equal lines marked on here. This whole line here is equal to this whole line here. They didn't make markings because it'd be hard to tell whether they meant the pieces equal or the whole things equal, but they do intend for those whole things to be marked as equal. And of course, they want us to prove, Michael, that
Triangle AED is congruent to triangle BFC.
all right, once you got that down, 2 columns, statements, reasons. Any clang? Nothing. This is going to be all analytic. Let's look at what we're trying to prove. Trying to prove that AED, that's this triangle here, is congruent to BFC, that's this triangle here. What do we already have as far as congruency goes? I got sides here, yep.
And side.
I got sides here, the yellow ones. That's it. What am I missing then?
Angle.
Either sides or which angles if we went that route?
D and C.
D and C. Anything that I could use to get those 2 angles equal? Congruent triangles. Yeah, that didn't help, right? Okay, what sides would need to be equal, class?
A, B, and B.
AE and BF. At your seats. Follows exactly the same process we just used. At your seats, do the proof. I'll give you a 2-minute head start and then I'm putting it up. If you need to look back at the previous proof, you can coach yourself through the steps, but you need to get good with this process. When parts are equal and you need wholes equal. Whole equals sum of parts, addition, substitution. All right, how many perfect? You got all 5 statements, reasons. All right, questions. Abby?
Can you just state that with the equals here?
Well, it's the same thing on both sides, so it stands to reason. It would not be a problem to sneak in here that EF equals FE or EF equals EF by identity. Really, the only reason we would need the identity, though, is if we're using those 2 sides as being the equal sides in a side, or an angle, side, angle. But it wouldn't be a problem to state it, and if in doubt, include, right? Great question, good. Any other questions, comments? All right. New sheet of paper, or on the back side of the proof you were just doing. Look across the page now. And just a couple of problems above where the homework has been. Number 3 on page 119. Number 3 on page 119. No picture. No given. No proof. What do we do? We're going to come up with it ourselves. All right, go ahead and read number 3 for us, if you would, Lana.
Bisectors of the base angle of an isosceles triangle.
Usually, you're going to want to read something a couple of times to really make sure you understand what it's saying. So, Brecken, read it again.
The bisectors of the base angles of an isosceles triangle are equal.
One more time, Michael.
The bisectors of the base angles of an isosceles triangle are equal.
What you're going to think first is, what is the major big shape in the picture that I need to draw, class?
Isosceles triangle.
Start with the isosceles triangle. So, you could draw it however you want to. I'm going to draw it kind of tall and skinny. You could draw it however. And for uniformity's sake, let's name our triangle ABC. As you draw, state in the given what you drew. Given isosceles triangle, ABC, and with an isosceles triangle, obviously we know there's 2 equal sides, or at least 2 equal, but 2 equal sides. Let's specify which equal sides, with AC equal to BC. So that's the main shape. In addition to, or within this triangle that I drew, what else do I need to draw?
Bisectors.
Bisectors of the base angles. So I'm going to have to bisect angle A. I'm going to bisect angle B. Let's call these bisectors BX and AY. Since I drew them, I'm going to state them in the given. BX and AY bisect angle A and angle B, respectively. Or if you don't want to use the word respectively, you can say BX bisects angle B, AY bisects angle A, and that works too. Now, what are we trying to prove? Because that's everything it said to draw, right? Isosceles triangle with bisectors of the base angles. There was nothing else mentioned in there, correct? What did we want to prove in this proof, Noah?
That the bisectors of the base angles are equal.
Prove that the bisectors are equal. Well, what are the bisectors, class? AY and BX. So I'm literally just trying to prove that AY equals BX. Do you see how we're stating in letters off the drawing what we're trying to prove? Once you got this down, 2 columns: statements, reasons. You got your first statement and your first reason. I'm going to abbreviate respectively RESP. It doesn't have a whole lot of weight there. All right. Suggestion. Anytime you've got a bunch of different angles in the same picture, class, number 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know. Just a bunch of numbered angles. Clang and clang. Give me one of my clangs here, Abby. Angle 2 and angle 3 are equal. And on a similar note, but remember when I said if you've got two bisectors, it might be good not just to say that 2 and 3 are equal, 4 and 5 are equal, but class to say that 2 and 3 are equal halves. Let's use that wording. Let's say that angle 2 and angle 3 are equal halves of angle A, and angle 4 and angle 5 are equal halves of angle B. Reason, class?
Definition of angle bisector.
Definition of angle bisector. And that's going to be important because the other clang I was going to say is somebody besides Abby. Brandon? I was hoping for some new hands. I keep getting the same hands.
Wait, no, never mind.
What?
No, never mind.
Never mind. Brecken?
Angle 2 equals angle 5.
Well, we'd like to maybe get there possibly. I don't know, but no. Angle A equals angle B, right? We got two equal sides, equal angles. So let's say that angle A equals angle B because Noah.
In a triangle, angles opposite each side.
Are equal. There we go. In a triangle, angles opposite equal sides are equal. Now, here's the significance, right? Because A and B are equal, and 2, 3, 4, and 5 are all halves of equals class,
Angle 2 equals 3.
2, 3, 4, 5, they're all equal. Angle 2 equals angle 3 equals angle 4 equals angle 5 because? No. No? Stay with me. Halves of equals are equal. Halves of equals are equal. That pretty much knocks out the clang, but I've got a whole lot of equal things here. Now, let's look at what I'm trying to prove. I'm trying to prove that AY, right here, equals BX, right here. Thinking analytically, how should I try to get these two lines equal? That's always a go-to, right? Congruent triangle CPCT. Okay, let me ask you this. If, come down to the bottom of the proof somewhere, if I'm going to be able to say that AY equals BX by CPCTE, this is analytic thinking, we're going to write it the way we think it, which triangles should be equal?
ABX and AYB.
Yeah, ABX and BAY. Do we see that? This triangle down here and this triangle down here. If those two triangles, if triangle BAY is congruent to triangle ABX, then these lines are going to be equal by CPCTE, correct? What do I already know about triangle BAY? In fact, I'm going to draw it off to the side. And triangle, make sure this is showing up. There we go, it is. Triangle XAB. I know that A and B are equal, right? And this little angle is the 4, and this little angle is the 3. So class, I know that those two angles are equal. What's missing to get the triangles congruent? Adam? If I want these two triangles congruent, I've already got two angles here, I got two angles here, but angle doesn't prove triangles congruent. I gotta have some sides somewhere. Which side, Adam, AX, AB, BX, do I want to get equal to either like AY, BY, or AB?
AX and BY.
That would give me side angle if I could get these two sides to be equal. Could be a challenge to get those two sides equal, though it could be done. It's just a very convoluted way to do it. Lana?
Oh.
Adam?
You say AB equals BA.
Oh, if AB equals BA, class, I have angle side angle. So that's going to be my reason here. I just need angle side angle. And it's going to be angle side angle because AB is going to equal BA class by identity. Do you see the synthetic analytic meet in the middle approach. Again, you don't necessarily have to write it out this way, though this turns out to be statement and reason 5, statement and reason 6, statement and reason 7.